In Tutorial 5, we completed the design of our maximum height panel. However, the panels to the left and right of this panel have not yet been designed. The Extend Left and Extend Right buttons allow the designer to extend a given reinforcement design to all other panels, then modify as necessary. As you get more familiar with this technique, you will develop your own methods of applying your grid designs throughout the wall, but we will show you one. Since we have started at the highest panel and the loading is also the worst case at this point, we can rest assured that if our Geogrid length and layout works for this panel, it will likely be conservative for lower panels. This will have to be checked, but it is a good place to start. Keep in mind that at some point someone will have to construct this wall. The designer should always balance an economical use of Geogrid with a reasonable level of complexity in terms of the installation. By keeping the geogrids at consistent elevations throughout the wall, which is automatically done with the extend functions, we are preserving a consistent pattern for the contractor to lay the geogrids out. Over complex designs, that is, constantly changing geogrid lengths and elevations done in the name of economizing geogrid, often cause more problems during installation and potential down the road. To begin, we will extend our Geogrid layout to the left and right of the subject panel. We can see in our elevation view graphic the Geogrid design has been extended throughout the wall. Keep in mind the other panels have not been tested yet. We are just adding Geogrid to them. Our next step would be to get an initial idea of where our design stands for the wall as a whole. With the Include ICS button off, hit the Analyze All button. We can see that all of the panels are now green, signaling that all of the design criteria have been met for every panel, which is not surprising since we extended the Geogrid layout from the highest panel to lower ones. If a panel did not pass the minimum criteria, it would be shown in red. However, this design would likely be over-conservative as it stands, since many of the lower panels will have Geogrid lengths that are applicable to much higher sections. Now it is just a matter of fine-tuning the design. Every designer will have their own methods, but in general, it is good practice to leave a given Geogrid length for a number of panels until a threshold is reached where the Geogrid can be changed by a reasonable amount for the next number of panels. Since we want to keep the grid pattern the same and just modify the length to be more fitting to this lower panel, we hit the Minimize Lengths button. Vespa then shortens all lengths to meet the minimum standard for base to height ratio. This new grid length has to then be checked. Hit Analyze Panel. It appears the minimized lengths are satisfactory. Now run the ICS on this panel only. It appears the ICS analysis is also satisfactory. We can now extend the new grid length left of this panel and continue this process for all panels on the wall. Note that when the grids are extended left, they are turned blue again in the elevation view, meaning you have changed the grid design since the last time we ran the Analyze All button, and they have to be checked again. I will quickly go through and design the wall to ensure all panels meet the minimum criteria. That's it. Our design is complete with respect to internal, external, and local stability, as well as internal compound stability for both static and seismic conditions. If this wall requires a global stability check by the geotechnical engineer, Vespa is equipped to create an export file that can be checked by the global stability program GSlope, which is available through mitersoftware.com. To export this file, simply go to the File menu and select Export to GSlope. You can then pick the wall and the section or panel you want reviewed. The GSlope file will contain the wall geometry, soil conditions, and loading conditions. Now the designer can create a fully customizable design report. In the next tutorial, tutorial number 7, we will create a report and export our design to CAD.